All right, question number 6 says, suppose you wish to minimize a continuous objective function on a closed interval, but you find that it only has a single local maximum. Where should you look for the solution to the problem? All right, so we've talked about identifying the critical points. When you take the first derivative, set it equal to 0, that will give you the critical points for potential max or min. But if you only find the maximum, you also need to check the endpoints. So that's from the definition. We're going to find the one that says that. This one says determine the value of the x-intercepts. This one says determine the value of the function. Well, the first derivative is 0. That would identify max and mins, but it's already telling us that we only have a maximum. Determine the value of the objective function at each endpoint, and so there we go. So the endpoints will give us either a max, the minimum value if you only find a maximum, having done the other test. All right, number 7 looks like a review, wants to determine if the mean value theorem applies. And then if so, find the approximate point that guarantees by the existence of the mean value theorem. So let's just remember mean value theorem is just a slope formula. So let's f of b minus f of a over b minus a just says that the slope at some point is going to be equal to derivative at some point. So that's all we're doing. We are looking at the function f of x, x plus 1 over x on the interval 1 to 2. We cannot use 0 in our domain. This interval does not use 0, so this is going to be continuous over this interval, and we can take the derivative. So we will at least satisfy that part. So we are going to find f of 2. We're going to find f of 1. I'm going to find the derivative. So we have f of x is 1 over x plus x. So let's evaluate all these. F of 2 will be 1 over 2 plus 2, and f of 1 will be 1 over 1 plus 1. So this is 2.5. Or if you want to change it to a improper fraction exactly, which is what we would like to use, 2 times 2 is 4 plus 1 is 5. So we get 5 over 2. And this one would just be 1 plus 1, which would give us 2. All right, so we got f of 2, f of 1. Let's find the derivative. Derivative, I wrote it backwards, but it should work out the same. I'm going to think about this as x to the negative first power plus x multiply power. It'd be a negative 1 times x minus 1, be a negative 2. Power times 1, which would just be plus 1. So if we clean this up, this will be 1 plus 1 over x squared is our derivative. And so we're going to set slope equal to derivative and solve for x to find that point. So our slope, f of 2, f of 1, this is going to be 5 over 2 minus f of 1, which will be 2, all over 2 minus 1. That's going to be equal to 1 plus 1 over x squared. All right, so let's simplify this a little bit. 2 minus 1 is just 1, so we'll just have 5 over 2 minus 2 equals 1 plus 1 over x squared. All right, to get rid of fractions at the same time, I'm going to multiply both sides by 2x squared. So the 2 will cancel out the 2, x squared will get rid of that, and then we'll get a better function. I'm going to write the result down here. So when I multiply by 2x squared, the 2's cancel, and I'll just be left with 5x squared. 2x squared times a negative 2 minus 4x squared. 2x squared times 1, 2x squared. And then 2x squared times this term. The x squared will cancel. 2 times 1 will be 2. All right, so combine 5 minus 4 will just leave me with x squared. We can subtract 2x squared. That will zero out. 1 minus 2 will give me a negative x squared equals 2. Make sure we haven't missed something. Okay, I did. I'm looking at this. I should have had a negative in front of this term. So I'm going to go back and fix that. So this should be negative. Over here, this should be negative. This should be negative. So when I multiply, this should have been a negative 2. Okay, so sorry, one sign change. Negative, negative. This should be negative. Divide by negative 1. And then this gives me x squared equals positive 2. Then we will take the square root of both sides, and that will give us x equals positive or negative square root of 2. So we get 2 solutions. We got to remember we are on the interval positive 1 to positive 2. And so the only solution that would be within there, we will get rid of the negative square root of 2 and only consider the square root of 2. That's about 1 point something. So square root of 2 will be our answer as far as x equals the value that makes the slope equal to that point between 1 and 2. That's the value that we're guaranteed to exist. All right. So first part A, does the theorem apply? We are saying yes, it's continuous on this interval and differentiable. All right, then part 2, the points that are guaranteed to exist. Square root of 2, positive square root of 2.